Right, so we're going to write down that the magnitude, all vectors must have magnitude and direction. Okay, so direction is easy enough. It tells us in the vector, if it's going from A to B or from P to Q. The magnitude of a vector is its length. Okay, its length or its size. Its length. One end of the vector to the other. So, some notation for the vector. For the vector A to B. Magnitude is notated as so it's A to B again, except two straight lines. Okay. Where have you seen these like two straight lines before as well? Absolute value. Okay, so it's the I suppose the distance. Okay, the absolute value from A to B. Okay, so that is the length of the line. So let's see if we can figure out. So for, let's say if A to B starting position, let's say at A, and let's give it a coordinate. And A to B is the vector -3, 5. Find magnitude of A to B. So I'm just going to do a little sketch. So first thing I'm going to mark on here is what? Yep, I'm going to mark on A, which is 1, 2. So that is point A. And then to find the vector, to show the vector A to B, how do I do that? Ari?
Sorry.
So to show the vector A to B, how am I going to go about doing that? I've got its starting point.
Oh, you just so A to B.
Mm-hmm.
You do 1 over, not 1 over 2, but 1. What am I trying to say? You do -3 over 5, and you. What do I say?
Okay, how can I display A to B on this diagram? I've got A, I need to get to B.
Oh, then you just do down 3, and then.
So remember the
Sorry,
top
not
one,
down 3, not down 3, left 3.
right? The
Left
top one
3
corresponds to the X.
goes the X, and
So
then 5
1,
is up.
2,
Sorry.
3, and then 5 up. 1, 2, 3, 4, 5. So that is B. And then we can draw it in. And after I draw it, what must I make sure I put in, Lily? An arrow, correct. Because I'm going from A to B. So thoughts, how can I work out the magnitude of this line? Right. Let everyone get caught up. All right, so we can see that this makes our right angle triangle. Very badly drawn. And so to work out the magnitude of this line, yep, go ahead there, Marco, tell us what to do. Yep.
The vertical side, I'll call it.
Yep.
Bond is 3. The vertical side is 5.
Yep. So it's going to be
Square root. 3 squared is 9. 5 squared is 25.
9 plus 25 is
36.
30.
Yeah. And then you find the square root of 30.
Yep. So the magnitude of A to B is the square root of 34, which is 5.83. Easy enough. Does it matter, looking at this, where the starting position is? No. Okay. It doesn't matter where this line AB actually starts from, okay, because we're told its vector is -3, 5. Okay, it is this that is the only thing that is going to determine the magnitude of the vector, okay? Because I can see that it's -3 squared. Does it matter if it's negative or positive? No, because when I square it becomes positive anyway. And I've got the 5 in the y direction. Okay, so this is the only thing that determines the magnitude, okay? Because it doesn't matter where I draw this line, it's always going to be the same length if it has this vector, okay? Make sense? Okay, what about this one? Gonna move it down to here. Let's the point A as position vector 3, 2. B has position vector 1, 4. Okay, so two things I want you to do. Find vector A to B, and then find the magnitude of A to B. And remember, if it's got position vector, what does that mean? Yeah, it starts at the origin, okay? So see if you can do it, if you need to do a diagram, but also see if you can do it without doing a diagram, okay? Alright, so to work out A to B, how did we go about doing that? Anyone? How do we work out A to B? There was a way that we did it last time. Come on, I need you to speak to me. Anyone? Okay, which is?
Position B, OB.
Alright, OB minus OA. Okay, B take away A. So O to B is 1 to 4, subtracting off O to A, which is 3 to 2. 1 take away 3 is -2, 4 take away 2 is 2. Okay. Just out of interest, can I simplify this? I cannot simplify this. It is not a fraction. Okay.
No.
Okay, I cannot simplify it. Maybe I'll come back to that in a second. Okay, so that is our vector. Now to work out the magnitude of A to B, I have to use Pythagoras. Actually, I can just do this. So it's going to be the square root -2 squared plus 2 squared square root of, so that's 4 plus 4 is 8. Did anybody simplify root 8? No? Come on, we should be. What's root 8 the same as? 2 root 2, okay? Because it's root 4 times root 2, which is 2 root 2. Okay? Now just to show this in terms of the picture, A is 3, 2. There is point A. So the vector O to A is right here. O to B is 1, 4. So 1, 4. That is O to B. Let's make sure we put in the direction. I want the vector going from A to B. If I want to go from A to B, I need to go from A to O. Okay, I need to go from A to O, and then I need to go from O to B. But remember, A to O is the same as negative O to A. Okay, it's just going in the opposite direction, okay, which is why I subtracted these, okay? I can also see here that I'm going 1, 2, so -2, 2 to the left, and then 2 up. And then we can see for the magnitude, all we did is we used Pythagoras on this triangle to work out the length of this line. Okay? So please remember this little formula, okay? You will need it, okay, especially next year. Just out of interest, Ari said, well, Ari didn't say, he checked himself, but the vector, if I was to divide both of these by 2, like what can you tell me about these two vectors? How are they not the same? direction is the same, the magnitude is different, okay? If I was to draw a negative 1, 1, negative 1, 1, it's going to be that green line there, yeah? So what can you tell me about the terms of its magnitude compared to the magnitude of AB? It's half of it, okay, which we can see, okay? It's the points are actually half, so the magnitude is going to be half, all right? But it's got the same direction. Are these two vectors equal? No, because remember, for vectors to be equal, they have to have the same direction and the same magnitude, okay? So just a nice little reminder there. Okay, so we're going to look at page 61. So this is practice 2. And Samara at home, you can get this, of course, on ManageBack.